And again, we're just sticking to whole numbers. You know, I knew this guy that he was a crop breeder, and what he did was he bred different types of fruit and made small crops, and if they were really, really good fruit, then they'd sell the trees to other people. I don't remember what his name was. I think it was Bradford Farms or something. And they have the record for like the sweetest peach ever or something like this. This was years ago. But what he did was that. He would breed some fruit and make some special trees, and maybe 5 or 10 trees for each orchard. Then you don't want to make a whole orchard of crappy fruit, right? Do you want to do that? No, you want to make a small orchard, and then if it's good, then you start making more trees. You get the idea, right? So what he did, he had 8 orchards. Each orchard had 5 trees. How many trees total are there? If there's 8 orchards and each one of them has 5 trees. You know, there's a couple ways we can do that. If you have 8 orchards and each one of them has 5 trees, couldn't you just do, there's 5 trees here, and there's 5 trees here, and there's an orchard with 5 trees. Could you add them all up? Would you get 40? One, 2, 3, 4, 5, 6, 7, 8. That's really quite annoying to do, isn't it? So instead of doing 5 plus 5 plus 5 8 times, notice the word I'm using, 8 times, that's where we get that word. Repeated addition is also considered multiplication. That's where we get it from. If you're adding the same number over and over and over again, we get multiplication out of this. So option 1, not so great. I mean, you could do it, give you the right answer. Or we could do multiplication. Again, how we get multiplication is simply repeated addition of the same number. I would spell repeat. And we have a way to represent that. Instead of doing the 5 plus 5, we typically see it. How would I write this another way instead of 5 plus 5 plus 5 plus 5? How do I write it?
5 to...
Okay, we have an 8 because there's 8 orchards, and then
Times 5.
how do I write times 5?
X. 500.
Okay, I could use a little x. We could do that. That's 8 times 5, right?
Correct.
Sure. Now, we are going to get away from the x after a while because if you know anything about variables, which maybe you do at this point, we haven't introduced in this class, but variables are oftentimes x. So we have another way of writing this as well. We can also do a, what's the thing we can put in place of
like
the,
a dot?
yeah, it's a dot. It's not a decimal. It's a dot in between it. 8 times 5 means the same thing. There's also a couple other ways. Do you know them? The what now?
In fraction form?
No, that would be for division. That's a great call. That's a good
Put the
idea.
5 in parentheses.
Exponents would be repeated multiplication. You guys are on the right track. Go ahead.
Parentheses, put the 5 in parentheses.
We can do 8 times 5 like this. We're going to get away from this one. We can do 8 times 5 like this. We can do 8 times 5. Have you ever seen that before?
Yeah.
That right there is implied multiplication. Whenever you have a number next to a parentheses like this, it says this number is getting multiplied by whatever is in there. Make sure you know that because this is going to happen a lot in this class. Like this, or we could even have 2 sets of parentheses next to each other. That also means multiplication. So all 3 of those are things we'll be seeing over and over again. By the way, how much is 8 times 5?
40.
Just like we had for addition and subtraction, we have a couple words for multiplication, these little parts up here. The 8 and the 5, fun little words we'll be saying a lot. Factors. 8 times 5, the 8 and the 5 are called factors, the things you're multiplying together to get this answer. And the answer, what we get after we multiply, do you know what it is? And addition was a sum, subtraction was a difference, multiplication would give us a, do you know it? You've heard it before, I know you have.
The
Say it.
product?
Yeah, say it louder.
Product.
Yeah, you both said it. Product, exactly right. So if you're asked to find the product, what it means is you're supposed to multiply. Before we get into some actual examples, I'd like to talk about some properties of multiplication with you. And hopefully I'm going to draw some conclusions that are kind of interesting, and we're going to compare these to some other operations we've already done. First one's this. If I multiply 0 times any number, for instance 0 times 1, how much am I going to get if I multiply 0 times 1? 0. Okay. What happens if I multiply do it the other way, like 1 times 0? Does it make a difference?
0.
Oh, it's still 0. This is called the property of 0 for multiplication. If you multiply 0 by anything, you're going to get 0. Or anything by 0, you're going to get 0. The property of 0. How about this one? What if you multiply a number by 1? And either way, 1 times 8 or 8 times 1. What's that going to give you?
8.
Does it matter that it's 8, or anytime I multiply by 1, am I going to get that number back?
Yes.
That's an identity right there. I always get the same thing back. So here I get 8, here I get 8. This is the property of 1 for multiplication. This is a good one. Does it matter if you multiply 5 times 7 or 7 times 5? Are you going to get different answers there?
No.
Are you starting to see similarities between this operation and one other one we've done before? Think about it as we're writing this down.
Addition.
Did subtraction do this? Was subtraction the same if I reversed them? Was addition the same if I reversed them? They're both what we call commutative. There's two more. The second one is this. If I take, remember those parentheses? What do those parentheses mean again?
Do this first.
Great. So if I have 2 times 3 times 5, or 2 times 3 times 5, and I group them here, or I group them here. Remember, these, I don't even actually need that dot. It's implied that I'm multiplying, and it's implied that I'm multiplying. Am I going to get two different answers for these? What do you think? Do them in your head if you think so. Let's take 10 seconds, do them in your head. Do this part first, then do that. Then do this part first, then do that supposed to be 2. I don't know, you tell me.
It's 30.
30.
Either way you go?
Yep.
2 times 3 is 6.
6 times 5,
That's
right?
30.
30.
15 times 2.
15 times 2 is 30.
So either way, we're getting 30 out of this. Do you remember that addition did the same thing? Addition, it didn't matter how I grouped them or associated them. That was the associative property. We have that here too. Associative property. You're going to find that a lot of these properties are similar to addition. Why is that? Someone take a guess as to why multiplication is so similar to addition.
Because it's repeated addition.
That's exactly right. We're just repeating these properties over and over again. That gives us the properties for multiplication. Since multiplication is repeated addition, a lot of the properties carry over. Now there's one more that we haven't talked about in addition because it doesn't happen in addition that I do need to discuss here with you briefly. You're going to be using this property a lot. Kind of a cool one, actually. And it happens here when I have a number outside of some parentheses and then some expression of 2 or more terms inside. So we're having 2 outside, I'm multiplying it by 3 plus 4. Now there's 2 options we have to do this problem. We are most likely going to use the order of operations way to do this, but I want to show you right now that there is a different option. This will help us out a lot when we get into variables. This is called the distributive property. What the distributive property says is this. I can take my 2, and because this is being, what's this operation between here again?
Multiply.
Because it's multiplication, I can multiply the 2 times the 3 and the 2 times the 4 and then add them. That's the distributive property. It's kind of cool. I'll show you what I mean. This is the same thing as 2 times 3. Notice how the 2 is being multiplied by the 3 plus, because we have a plus, 2 times 4. The 2 gets multiplied by the first and the second number, and we're still adding them together. Let's see if this actually works, okay? How much do we get out of this one?
6.
Plus,
8.
how much is that?
14.
Now let's do it the other way we should know how to do already. This way. We would do 2 times, what's the 3 plus the 4?
7.
7.
How much is 2 times 7?
14.
Looks to me like they're the same thing. So distribution does work exactly the same as if you were to go through order of operations. That distribution is something we're not going to use a whole lot now, but later on we're going to be using all the time when we get into variables. How many people understood what we talked about the properties so far? Feel okay about those? Good, all right. All right. By the way, you do need to memorize your multiplication table. You know the multiplication table that says like 9 times 6, and you go, ah. You have to think about it and use the whole 9 method. You've seen the 9 method, by the way, haven't you?
Yeah.
The 9 times 6. Oh, I love that. It's so cool. You do 9 times 6. 1, 2, 3, 4, 5, 6. The answer is 54. Have you ever seen that before? You've ever seen that? Oh my gosh. You do 9 times 1. Let's do 9 times 1. 9. 9 times 3. 2. That one's hard for me. 27. You see that? Isn't that cool? So you have your 9s down at least. 9 times 8. 1, 2, 3, 4, 5, 6, 7, 8. You got 70. Uh-oh.
2.
2. 72. Isn't that kind of neat? You can do your 9s that way. But you need to memorize all your multiplication tables. Some single digits, they have to be memorized. It's really important for us because we do have a method for large numbers, but if you don't know how to multiply like 6 times 3, and it's taking you a long time to think about that, it's going to slow you down. Now what I'm going to do is I'm going to let you use a multiplication, oh we're almost done, huh? Let you use a multiplication table on your tests. I'll hand them out before class if you need them, but I'd like you to start memorizing those things. Okay, we're going to end there for today. Yesterday what we did was we covered all the way up to large numbers with multiplication, and we talked about some of the properties, and I told you kind of need to memorize the single digit by single digit, like the 6 times 7, and you guys all say,
40.
let's try that again, 6 times 7, and you say,
40.
hopefully 42. Yeah, you need to have those down. I will give you a multiplication table if you'd like it, but you need to have those memorized, otherwise you're going to spend too much time doing that. Now today, we do have a method to multiply large numbers. It looks real similar to adding large numbers together, but let's cover this, and we'll move on to division after it. So multiplying large numbers. By the way, do you remember what this means?
Do this
Times.
5.
It does, the parentheses do mean do this first if there's an operation inside of that. If there's no operation inside of that, whatever number is outside means that you are great. Good, so we're multiplying, this really just means 29 times 6. So let's see if we can do 29 times 6. Does anyone know 29 times 6 off the top of their head? No, I don't either. If I thought about it, I think it's 174. But it's really hard to do that on top of your head. Why? Because that's not in our multiplication table. We don't memorize that, but we do have a method on how to do problems like this. And typically what we'll do is we'll line them up vertically, real similar to how we lined up addition. Only this time, instead of adding, we are multiplying. Do you remember the process, the algorithm, that means the process, for multiplying these large numbers? What do you do first?
Multiply the numbers on the right.
Okay, so what two numbers specifically am I going to multiply?
9 and 6.
Okay, everybody, what is 9 times 6?
54.
And just like with addition, when we have the 54, we only have 4 ones. What do we do with the other 5?
Carry them over.
Okay, now what?
6 times 2.
Uh-huh.
Plus
Plus 5.
Plus 5.
Perfect. So we're going to get the 6 times 2 is
12.
plus 5.
17.
Anything else?
That's it.
We're good. So we get 174. So that's one way that we can multiply these large numbers, line them up vertically, multiply each digit on the bottom by each digit on the top. We do need to remember place value holders when necessary. Here they weren't necessary, but we might see them sometimes where they are. Let's do a couple more examples here. How about 307? Remember that that dot also means multiplication. 307 times 81. Again, we'll line it up vertically. Really, it's going to line up just coincidentally by place value. In multiplication, we take care of place values. You can see this with our decimals in a different method. So we're lining up vertically just along the right-hand side. Like on the Word document, how it's right justified, that's really how we're lining these up. The 307, 81, we're multiplying. Okay, walk me through it. You've all seen this before. Let's just get this in our heads again. What's the first thing I'm going to do?
7, 1, 2.
And what are we going to get?
7.
Okay, great. What's the next thing I'm multiplying?
0,
0.
And how much do I get?
0. 0.
Good. That was one of our zero properties for multiplication. Next thing?
3.
Perfect. Am I done?
No.
No. What else?
Gotta put 0.
Put it through.
Good. You can put whatever you want, as long as you have a place value holder underneath the 7, because we're going to do the same process again, except not with a 1, but with this 8. Because this 8 is really an 80, we're just kind of ignoring that 1. It really is an 80. This is 80 and a single 1. We need a place value holder, because technically what you're doing is you're multiplying by 80, and you're just adding the 0 at the very end. That's multiplying by 10 very easily. So that's really what we're doing. The place value holder just lets us do that. You can use a 0. I honestly prefer an X. That way don't forget to have a place value holder. So I'll put a little X down there. You can put a smiley face if you want. I don't care what you put. As long as you have a place value holder to mark that now we're working in the tens digit. So we move on. What are we going to get next?
57.
56.
56.
That's right. So put our 6 here.
Carry 5.
Perfect. And then what do I get?
5.
0 plus 5.
Good. So we still add the 5, even though we got the 0, we got the 5 down. And lastly, everybody, what are we going to have?
24.
Hey, what do we do now?
Add.
Since these are already lined up for us, we can add this digit by digit, because really we're just doing multiplication separately and adding the products together at the end. We'll get the 7, 6, 8, 4, 2, making this 24,867. How many people are okay with this large number multiplication? I want you to try just one on your own, work all the way through, see that we can all get the right answer. These are the ones that I am going to give you these on a test, and you can't use a calculator with it. So I need to make sure you can do it, but man, this is a real easy way to get 5 points on your test. Just make sure you don't go so fast, because if you think you know it, you're like, I don't know this, it's just below me. If you go so fast, that's when you make those mistakes. So take a little bit of time, make sure you understand the concept here, and get the problem right. There you go. Recall that that actually means multiplication as well. Those two parentheses next to each other. Is there any more homework that needs to be turned in? Because I need that at the beginning of class.
Things like I bring up the book, things like part of the concrete.
Or you know, for one time, if you want, you can use to remove one of the in my office. With your office? Science people. Okay, let's see what happens with this thing. So of course, hopefully you set this up vertically. Does it matter which one is on the top?
No.
Not really. We typically put the larger number on top for some reason. It looks better. But we're just going to multiply digit by digit until every digit on the bottom is multiplied by every digit on the top. We're going to use those place value holders like we need them. So the 6 times the 2, how much do we get there?
12.
And we'll carry that. 4 times 2, or 2 times 2, I already gave it to you.
5.
Yeah. And then other one?
14.
Next we're going to put a place value holder. Just one of them because we're moving to the 10 spot. I'm also going to erase that because I don't want to count it twice. That wouldn't be a good thing. So the 4 times the 6, how much do we get there?
24.
We'll carry that 2. Then what are we going to have?
10.
Good. We have the 8. We add that 2. We get 10. After that, what now?
29.
Perfect. Hey, what happens after that?
2x.
2 X's.
Yeah, we have to do it for every digit we move over, we have to do another place value holder. So now that we're on the hundreds spot, we need to make it look like hundreds. We put 2 zeros there, 2 X's. So we're going to do the 1 times 6 is 6, 1 times 2 is 2, 7. Finally, we'll add them all up. We get a 2 in the 1s, a 9 in the 10s. We're going to have to carry over one of those hundreds. We'll have, well, let's see here. This should make, how much?
13.
Yeah. 13 and,
10.
perfect. Put a comma in there where we need it. Yes.
You said erase, like, whenever you carry over. Do you want us, like, to do that in the homework too? That would, like,
That's
look
up
like
to
we're
you.
not showing work.
It's just a tool for you. I like to erase it, that way I don't make a mistake and actually accidentally add something that I shouldn't have. So typically I would do that on my homework. Like I would just erase it, take the time. It just saves me the trouble of kind of getting confused there. It's just something I'm showing you. If you do it or not, that's really up to you. Okay. How many people got 103,092? Awesome, very good job. We're going to move on from this large number multiplication because this is really it. I mean, we can make problems longer, but the same process holds. So we'll move on into one other aspect of geometry that we covered perimeter last time. Do you remember the perimeter that we covered? Perimeter was the distance around our figure, around a polygon, which just meant a shape that has straight sides. We're now going to talk about area. Someone out there, why don't you give me like a typical person's definition of area?
The space inside of something.
That's a great definition. Did you guys hear him back there?
No.
Say it again, because that was good.
The space inside of something.
Yeah, that's what area is.
Square footage of a house.
Square footage is a way to represent the area. We could say square inches or square miles. Wyoming has a whole bunch of square miles in it. Acres is another way to represent this idea.
I've
Yeah.
always known it as like in the floor, the squares in the floor.
Yeah.
Show how much the
Mhm.
limits are just about the side.
Right, and these squares, if you look down right now, that's about 1 foot by 1 foot. I think those are foot squares. If you look down at those squares on the floor, they're each covering an amount of surface of the floor. Do you see what I'm talking about? That amount of surface is the definition of area, space or surface of some object. So when we define area, we say that area is really the amount of surface of a region. Surface or space. That's a good one too. I like that. One important thing about area have you ever heard of, I know you guys have heard of this, the square footage of a house. You ever heard of the square footage of the house? You probably know how much square footage your house has or someone else's house has. I don't have very much square footage, unfortunately, but that's okay. Maybe you have a large house, you have a lot of square footage, or a small house, you have not a lot of square footage. Let's say you were going to recarpet your house or your room or something. Are you going to walk into Home Depot and go, hey, I need 200 inches of carpet, or I need 10 feet of carpet? Does that make a whole lot of sense? Or 200 feet of carpet?
Think about yards.
What about that? Do you need 200 yards of carpet? That doesn't make a whole lot of sense, because when we're talking about area, we're not just linear. Linear means in a straight line. We're not just one-dimensional anymore, we're two-dimensional. And to represent an area, you can't say just inches or feet or yards or miles anymore. If you're talking about area, we use what are called square units. You ever heard of square units before? I know you have, because you've heard of square feet. So you'd go into Home Depot and you say, yeah, you're not going to say I need 200 feet of carpet. You'll say I need like 200 square feet of carpet, or I need 200 square yards of carpet, something like that. That would represent to them how much space you need to cover. Are you guys with me on this idea? So make sure when we're doing this area, we're not just putting feet, we're going to put square units. Whatever the units are, inches, miles, feet, yards. Now, let's see if we can figure out how to find the area of some certain figures. What happens if your room is, well, rectangular in shape? Let's make sure that's a rectangle. What would happen if your room is, let's say, 15 feet by 12 feet? Your room is 15 feet by 12 feet. First question I have for you is this. Don't answer before you think about it. Can you find the perimeter for this room?
Yeah, each side. Add on.
So the perimeter's not the area, right? The perimeter, why don't you find the perimeter for me real quick? Just do it in your head. You don't have to say it out loud. Find the perimeter for me. How much did you get? 54. 54, great. That would be like the baseboard idea. If you were buying baseboards for this room, you'd have 54 feet of baseboards. Now for finding area, there's a different way that we're talking about that. We don't want to say 54. 54 would just be the distance around the room. We want the surface area of this room. How do you find the surface area of a rectangle? Do you know how to find the area of the rectangle?
Times the side.
So like you said it? Great, okay. Whatever this side is, times whatever this side is. Or the length times the width. Or some people have it, the base times the height. Either way you want to think about that, you're multiplying one side times the adjacent, that means right next to its side, the adjacent side. So in our case, the area, perimeter we got already. I had to do that. Perimeter is 54 feet. The area, for our area, we would be taking 15 feet times, or I'll use the other one for us, times 12 feet. Has anyone figured out what the 15 times the 12 is?
So the perimeter would be adding it up, or?
Yeah, the perimeter is adding up all the sides. It's the distance around
4 sides, right?
all four.
212 and 215.
Exactly. So I don't just want to do 15 and 12 because that's only half my room. Right? So perimeter means I'm adding up all four sides. The area though, we're just talking about one side times the other because that's going to cover the entire thing. In fact, if you broke this up into little squares, 1-inch squares, you had 15 of them going this way and 12 of them going this way, and you counted them all up, you would get how many of them?
180.
100. Yeah. Did you get 180? So in our case, it'll be 180. Do we put feet?
Square feet.
Square feet. Square feet. So we're not just talking about a straight line anymore, we're talking about the surface of an area. We've got to use the square feet for that. Okay, you do need to know some words for multiplication. Just make sure that you know when we're talking about, actually, why don't you give me some words? If you say these words, it means multiplication. What are they?
Product.
Product, that's a great one. Product means to multiply. Someone on the right-hand side of the room, what's another word that means to multiply?
By.
By, yeah, by could be 15 by 12. That's a great one. Anything else?
Times.
Times is a good one. So those three are really the ones we use. We say find the product, we're multiplying. Something times something, something by something, we're all multiplying in those cases. So make sure that when you read those, we know what to do. Thank you very much. Let's end our section with a couple of word problems up here. We'll see how to work these things, put a couple ideas together, and then we'll be done with our section. Let's say you work in a print shop, and your printer prints 16 pages per minute. It's pretty standard, I think. 16? About that. 16 pages per minute. And you need to print off a whole bunch of pages, and you're working for 45 minutes. Can you figure out if your printer prints 16 pages per minute, by the way, what does that word per mean? That per minute.
How many they could do in a minute?
Say that again?
How many they could do in a minute?
Exactly right. The word per means in each, for each minute. So this one is going to print 16 pages every single minute, and you have 45 minutes to work. How many pages could you print in 45 minutes?
You want the answer? Or?
I want you to figure it out on your own, but you don't have to say it out loud. Everyone's going to be doing this in a second. The first thing I want to ask is, how do we determine what type of operation we're doing, whether it's addition or subtraction or multiplication or division in which case do we use this? What are we going to be using here? And how do we figure that out? So if it says 16 pages per minute, how many pages could you print in 45 minutes? You kind of need to identify that we're having 16 pages for each one of those 45 minutes. Do you see what I'm talking about? Every minute you're getting 16 more pages. I'm adding those up over and over and over and over again. That repeated addition idea should clue you into, oh, this is a multiplication problem. Now I can multiply this. So this really is multiplication. We just multiply our 16 times our 45. Did you figure out how many pages you can print in 45 minutes? 720? Someone else say 720? That's a lot of pages.
Not really.
That's like that. That's what I watch. It's like that many pages.
I used to be a printer.
Oh, really? So you know all about this?
Oh.
He's calling your bluff.
I know he did,
I
right?
used to
What
do
if I was just making
32 pages at once at like 60,000 an hour.
60,000 pages an hour? So how many pages a day would you actually print off?
12 hours, you can do 800,000, 900,000. Since I left, they've got bigger and faster.
Okay, so 800,000, how much does it cost for each page?
I couldn't tell you.
No?
I mean,
Oh.
they throw away so much too.
Yeah, but how much would
I'm
it
paying
cost?
like 4 cents a page when I worked at a medical company.
It's 4 cents a
4
page?
cents for
So let's
one.
do that.
This is
Oh,
like-
we can't
These
use
are
the
like
decimal.
magazines.
Shoot.
These are magazines, stuff like that.
So if it's 800,000 pages a day and it's 4 cents a page,
That's
can you do
800,000 sections of 32 pages.
Oh my god.
so if you can do 800,000 times 32, then that would be the number of pages,
Yeah.
and then it's times 4 cents for each page. Let's
They'll-
do that,
they'll-
okay? Let's see how
They
much it
only count
costs.
the one section. Because It's all comes together as one. Then
Okay,
they
so
go and find it.
he said, do this with me. This is gonna be awesome. We'll have a lot of fun doing this. So we have 800,000 sections. Okay, and you said each section has how many pages?
32.
$25,600,000.
Easy, easy. Hang on. We're gonna all do it. I'm gonna show you some easy ways to do this stuff.
Yeah.
If you have a whole bunch of zeros, you can ignore those and add them on later. So for instance, if we have 1, 2, 3, 4, 5 zeros, what I want you to do with this, if you have just zeros, no ones or anything over here, what you can do, so do you all realize firstly that this is a multiplication problem? You certainly don't want to add 32 800,000 times. That would take you your whole life to do that, probably.
Yeah.
We instead want to multiply this 800,000 times 32. If we ignore these zeros, we can do 32 times 8, and then add those 5 zeros on afterwards. It's a way of tricking the problem for just a second. What is 32 times 8? Give me that.
156.
And then if we add on those zeros, 1, 2, 3, 4, 5, that's what you said first, right?
Yeah.
25,600,000. Now, here's one more thing. Each one of these pages cost, what did you say, 4 cents? About 4 cents. We're gonna do this. We're not to decimals yet, but I'll show you a little trick on this. If you're gonna multiply something by 4 cents, 4 cents is 0.04. Are you all with me on the fact that 4 cents is 0.04 of a dollar? Okay. We're going to multiply by 4, and then we'll move our decimal place 2 spots afterwards. So we're going to take this and times it by 4. Again, we can ignore these zeros. So we'll just do our 256 times 4. Which you all know how to do now. Did you get 10,024 also?
Yeah.
Add on those 5 zeros again. Let me recap what we've done just so I don't want to lose you here. So what we did, in order to do this problem quicker, we're ignoring these 5 zeros for just a moment. We're ignoring them and doing the 32 times 8. We put our 5 zeros back, and that's the correct answer. Now what we're doing is we're multiplying by 4 cents. We're going to ignore this 0 for a second. We'll be moving the decimal place in just a moment. We're going to multiply this all by 4. Again, we can ignore these 5 zeros. We'll do that right here. Put the 5 zeros back, but now we got to take place of that decimal. Or we have to take account of that decimal. Since we moved it, we got rid of it for a second. We got rid of those 2 decimal places. Let's put it back. And this is how much it costs them every single day to print that amount of pages. If it's 4 cents a page, that would be $1,024,000 a day to print that many pages. Is that useful information to you if you're a company?
Yeah.
Probably. You're going to want to budget that, right? You're going to say, hey, I'm printing $1 million a day. Probably going to need to budget that. That's a tremendous amount of print. Where did you work? That's crazy.
It's called quad, but color press. Web core quad.
That's amazing. How many people understood that? Feel okay about this whole multiplication thing? Good. That's great. That's great. Let's do 2 more examples for us. You know what? We'll make it 1. We'll make 1 more example, and then we'll move on to the next section. This was a good one for us. Scared me, honestly. I almost gave me a heart attack there. So I'm jumpy today or something. You ever been to Disneyland?
You?
How many people have been to
Once or
Disneyland?
twice.
Disneyland, in case you haven't noticed, maybe you haven't noticed because most of you are quite young. Have you noticed that it's gone up in price? Have you noticed that? It used to be about, yeah, seriously. I think it cost like $45 when I was in college per person. And that was for one park though. And now I don't even know if they sell one-part tickets. Someone who's been to Disneyland within the last 6 months, within the last 3 months. How much did it cost you for an adult?
It's over 50, I can't quite remember.
Oh, it's definitely over 50. I know
That's the
that.
single, I think the park offers
No,
like
it was
68
for
or
the
72.
senior
Yeah. Mine was free.
Oh, okay.
Well, actually, I had to pay 2 something.
Yeah, that's a fun deal, isn't it? I used to chaperone the senior class trip down there. I love that thing. It's awesome deal. Anyhow, I know it's like over $100 to do
That's what your TV was.
for a 2-day park hopper, right? 120. Let's say this. How much are the kids? Do you know the kids ones?
I paid my son, he's 3, and I'm like, are you kidding me? It's probably, he's like $20 less than an adult, maybe.
It's like $100 still?
Yeah.
That's ridiculous. He's not even gonna
That's
remember
what I
it.
said.
He's not even gonna know. Like 5 years down the road, we went to Disneyland. You're lying. Seriously. Which just shows you, shouldn't you just take your kids and take them to a park and go, this was Disneyland? They're not gonna know the difference. I'm kidding. That would just be Jack. Okay, so we're gonna take our family to Disneyland. There's a show called George Lopez. You ever seen the George Lopez show?
Yeah.
They always talk about stuff like that. It's really fun. And we said that adults cost, we'll make it up, we'll say $125 for like a 2-day park hopper deal. And kids cost, we'll make it $105. I think it's pretty, yeah, I really do. I think it's close. How big's your family?
4.
Family 4. Let's make it family 5. We'll do 2 adults and 3 kids. So we're going to take 2 adults and 3 kids to Disneyland. Let's figure out how to solve this problem and figure out how much it's going to cost us for 2 days of magical fun.
Happiest place on earth.
The saddest place on earth?
Oh.
Yeah. Who says happiness is free? It costs a lot of money. So you got 2 adults.
We do the food line.
Those churros, though, man, they're good.
You gotta pay for the food. It's like $30.
Yeah, I know. Yeah, this is without food, right? This is
Yeah,
just
this is
just to
yeah,
get in the door.
Get in the door.
And 3 kids.
$3.75 for a bottle of water.
Oh, I know. $10 for a little bitty burger. You need 13 of them. Oh my gosh. Food's expensive. It's good though. It's good burgers. Okay, so we have 2 adults and we have 3 kids. Someone out there, I'm looking at the right-hand side of the room. Left-hand side, you guys have been great all day. Right-hand side, I haven't got that much out of you. Let's work on this together. What's the process for getting this down, for figuring it out? What do we need to do? Is this just a single multiplication problem, do you think?
No.
Okay. So give me one thing that we are going to need to multiply though.
1.5 times 2.
Good, great, because we have 125 and 2 adults. So that's one thing we're going to do.
Couldn't you like, with that, you could just like add 2.
We could add those together, right? Because multiplication of times 2 is really just repeated addition once. Or if you really want to, you could just add 2 125 times. Kind of lame, but you could do that. Okay, so great. We're going to be able to figure this one out. How do we calculate how much your 3 kids are going to cost? Okay, 3. The 125 again?
105.
So 105 times 3. After we figure out these products, how are we going to figure out the total?
Add.
Add the 2.
So if we add those together, that's what the and actually means. Add them together. We're going to have the 250. We're going to have the 315. Hopefully that's 315, right?
Yeah.
How much?
565.
That's less than I thought, really. I thought it was going to be like...
Damn.
If you book it in advance, they might throw it.
They might give you a pair of ears. Oh, it makes it all worth it after that. So to go to Disneyland for 2 days is going to cost you $565. Go have fun.
All right.
Have a great weekend. But that's, at least you can figure that out ahead of time, right? You don't want to go down there and stand in line, and then they go, yeah, that'll be like $1 million. And you're like, oh, what the heck? So at least you can budget this way. You figure things like that out. I don't know either. You got 250 here? Okay, one more thing. In your book, they have a couple sections before every section of homework that talks about how to use a scientific calculator. If you are awesome with a scientific calculator, give yourself a pat on the back and skip those sections. If you don't really know how to use a calculator, would you please read those sections just before every one of the homeworks that we do in this classroom? It will show you how to use it. It will give you all the buttons laid out and say, this is how you manipulate your calculator. It's really a good idea. If that doesn't work for you, come and see me and I will show you in person how to do that. Okay, we're done with 1.5.